In this video, we're going to be talking about simplifying rational functions by factoring. In order to do this, I want us to look at this simple fraction, 48 over 36. And by simplifying, I'm also talking about reducing down. So when you're looking at this type of fraction, we notice we can reduce it. In order to do this, we see the shared factors here. So 48 can be broken up into 6 times 8, and 36 can be broken up into 6 times 6. And notice, since we're multiplying both in the numerator and denominator, these 6's can cancel out because 6 divided by 6 is 1. So when we have a numerator divided by a denominator that cancels, or that goes to 1, we can cancel it out. And we're left with 8 over 6. That would be how we're reducing fractions. Simplifying is the same way. So looking at the function or expression 63v divided by 49v squared plus 21v. 63 can be broken up into 7 times 9v, and the denominator can be factored using factoring out a greatest common factor. I can factor out a 7v from both terms, leaving me with 7v plus 3 in parentheses. Both of my 7's will reduce down to 1, so cancel, and so will the v, leaving in the numerator 9, and in the denominator 7v plus 3. A second example, 15v squared minus 30v divided by 6v squared. Now, at this step, many of you will be wanting to cancel v squared and v squared right here, but we cannot cancel when we are adding and subtracting, only when we're multiplying, because this can be broken up into 15v squared divided by 6v minus 30v divided by 6v squared. It can be broken up because it has a shared denominator. So you can only cancel when you're multiplying. So I can simplify by pulling out a 15, or factoring out a 15v in the numerator, leaving me with v minus 2 divided by 6v squared. Now from here you can list out factors of 6 and 15, or you can just see that 15 and 6 will reduce down to 5 over 2, because if I were to factor out a 3 from both terms, those 3's would cancel and I'd be left with 5 and 2. And then notice that this v and v squared will cancel. You also can use exponent rules and subtract your exponents down to simplify, leaving me with a v in the denominator and then the v minus 2 in the numerator. The third example, n plus 6 divided by n squared minus 36, requires us to do a little more factoring here. N plus 6 is already factored down as far as we can take it. However, n squared minus 36 can be factored into n plus 6 times n minus 6. And notice that n plus 6 and n plus 6 here will cancel, leaving me with a 1 in the numerator and n minus 6 in the denominator. Final example, p squared minus 3p plus 2, all divided by 7p minus 7. In the numerator, I can factor this expression into p minus 2 and p minus 1, and then I can factor the denominator into 7 times p minus 1, because I can factor out a greatest common factor between the two terms, that's 7. And then notice that this p minus 1 and p minus 1 factors will cancel, leaving me with p minus 2 divided by 7. I want you to note, you can only cancel out factors that are multiplied. Not that are added or subtracted. Thanks for watching.